and welcome to your energy final review. So I'm just going to be talking about the PowerPoints for those of you who couldn't come on Saturday or who wanted to hear it again. The first slide is just telling you how many questions there are about each topic. So our first topic is going to be forms of energy. There are 7. So starting at the top, mechanical energy is the total of all of your potential and kinetic. And so in order to have mechanical energy, usually you think about things that are moving, okay? Then we all know what sound energy is. We know that sound is caused by vibrations through matter. Chemical energy is going to be energy that is stored in chemical bonds. Examples of that would be batteries, food, and fuel, and logs, and gasoline, and coal. Then you have electrical energy. Anything that gets its energy from a plug or a battery or things like lightning have electrical energy. Light energy is also called radiant. Do not forget that all forms of radiation are considered light energy. So X-rays, microwaves, radio waves, and then of course the visible light that you can see. Then you have heat energy, which we also call thermal energy. So anything that has heat has thermal energy. So you have thermal energy. It's caused a lot by friction. So most energy transformations are going to include thermal energy. Then you have nuclear energy. Nuclear energy is pretty rare. It's found in the nucleus of an atom, which we're going to talk about next semester. Nuclear energy is what actually powers stars like our sun. You can also find it in nuclear power plants and nuclear bombs. Okay, so just practicing a couple of these things. If you look at the flashlight up here, you know that batteries have chemical energy, which they turn into electrical energy, and then the light bulb takes the electrical energy from the battery and turns it into light. And of course, when you have light, you're going to also have heat. Okay, your food has chemical energy, and then that is transformed into mechanical energy, and definitely some thermal energy, and some other types of energy that are going on in your body. Plugging in a lamp gets its energy from the outlet from electricity, so that would be electrical to light and thermal. And then you have the engine of a car. Cars get their energy from gasoline, so that would be chemical. You also have the electrical energy from the battery. You have the sound energy from the engine, the thermal energy, and then of course mechanical. Alright, next topic is going to be about the law of conservation of energy and what that has to do with potential and kinetic energy. Okay? The math is on another PowerPoint, so we're not really going to worry about the math part of this. We're just going to worry about how to think about the relationships. Okay? So we know that potential energy is increased when something gets higher or if it has more mass. We talked a lot in class about how if you have a 20-pound weight and a 5-pound weight and you're holding them at the same height, the 20-pound weight would have way more energy when it hit you than the 5-pound weight would. So up at the top of the hill, this bike rider has potential energy. He's not moving, so he doesn't have kinetic. That potential energy is changed into kinetic energy as he starts to move. Your total energy is going to be decided by how high up you go. Okay? So energy can't be created or destroyed, so his kinetic energy is coming from the energy that he got at the top of the hill. So again, up at the top of the roller coaster, you have a lot of potential, not a lot of kinetic. Then you start to go faster, and your potential changes into kinetic, and so on and so forth. You can read that explanation at the bottom. If you want to find your total energy, which we consider mechanical energy, then you would add these two things together. So in this situation, our total energy would be 100 joules, because 100 plus 0 is 100, and it stays 100 throughout the entire system. Okay, so your potential and kinetic, they will change, but your total is always going to remain the same. Remember, potential and kinetic are inverse. When one goes up, the other goes down. If you're looking for the place where they're equal, try about halfway down the hill. And then don't forget energy is measured in joules. Okay, so not really going to talk too much about the math here. There's another PowerPoint about the math. If you need help with the math, you can come see me Monday morning or Tuesday morning, and I can help you with some of these math problems. All right, moving on to the thermal energy and how it moves. So we have conduction, convection, and radiation. And before we even talk about those three things, you need to remember that heat always moves from high to low. So from the hot temperature to the low temperature. There's no such thing as cold, so it cannot move. Heat is energy, so energy will move from areas of high concentration or high heat to low heat. Okay, so conduction is going to be caused by direct contact where the molecules or the particles run into each other and transfer the heat, kind of like dominoes. Okay, things that are metal are really good conductors. They get hot really fast, they get cold really fast. Then you have convection, and that only happens with liquids or gases, because remember in liquids and gases, the molecules are not locked in place like in a solid. They can actually move around and flow. That's why we call them fluids. So when things get hot, they speed up and they spread out because they have more energy. And so when they spread out, it makes them less dense or less packed together. So hot things are going to rise to the top, whereas the cold things are going to be more squished together and they're going to sink down to the bottom. Just like if you go into a swimming pool and you want to sink, you're going to ball yourself up, and if you want to float, you're going to spread out. And then finally you have radiation. And radiation doesn't need molecules or matter at all because it's transmitted in waves. And that's how we get our heat from the sun. Okay? So if you're looking at these different situations where heat's being transferred, this top one would be conduction, as would this one and this one. Okay? Because you have solids that are transferring heat by direct contact. If you're looking for examples of convection, the fact that this little spiral thing will spin will have to do with the air or the gas heating up and spreading out, and you would actually be able to see that because the stream would spin. Also, a hot air balloon would be convection, as well as this bottom picture where you see the arrows. And then radiation would be the fire and the heater as the heat is traveling in all directions. All right, 3 questions about phase change diagrams. And these you just have to memorize, okay? Remember again that when things are cold, they have a low temperature, they're not moving a lot. And when things are hot, they have a high temperature and they're moving a lot. And notice that these particles or molecules are really, really spread out, okay? Alright, so solids have the least amount of energy. They're going to be at the lowest temperature. When you add heat to a solid, the temperature is going to increase until it gets to the special place called the melting point. The melting point is the temperature or the amount of energy that it takes to actually break those solid molecules apart to start to turn it to a liquid. The temperature is not going to increase until everything has melted, so there's no solid left. If you're talking about water, there would be no ice left. Once everything is melted, then the temperature starts to rise again and you have a liquid. The liquid is going to get hotter and hotter as you add heat. The temperature goes up, 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 until you get to another magical point called a boiling point. At that temperature, then the molecules of the liquid will start to break free of each other and become gas. Again, during a phase change, the temperature itself is not going to change, and it's going to stay constant until all of it, has turned into a gas, and then the temperature will rise again. If you're going in reverse and you're taking away heat, the gas would come together until you hit that boiling point, then it would condense, and then turn back into a liquid, freeze, turn back into a solid. Okay, so please make sure the biggest thing here is that during a phase change, the temperature doesn't change because all of the energy is going into changing that substance from a solid to a liquid or a liquid to a gas or so on and so forth. Okay, so that's probably what they're going to ask you about is why is this line flat? And that is because, like I said, the energy is going into changing the substance into the next phase. Okay, and this is just a blank one that you can practice on. So that's everything that you need to know about energy. If you need the math, then check out the math PowerPoint, which is in the overall review section at the bottom. And if you need anything, let me know. And if you need more help with the math, then come see me either Monday morning or Tuesday morning.